So I will be taking up the next problem here, wherein we need to draw the cam profile, which is having a lift of 45 mm, and it says that the follower is moving with the cycloidal motion during the lift, and it returns with uniform acceleration, which is also known as UARM, which stands for uniform acceleration and retardation motion. Okay, so they have given the nature of motion of the follower during the rise and return. Along with that, what additional data we have here is minimum radius of cam, which is given as 30 mm. We have the roller radius as 10 mm. Angle of ascent is given as 70 degrees, and angle of descent is 120 degrees. And angle of dwell between ascent and descent is 45 degrees. Okay. So with this data, let us start with the problem. So I'll just write down in terms of the notations here. Okay. The first one is angle of, see, I'm just using the different terminologies that are used in different textbooks. It's also called as angle of rise or angle of ascent. Okay, this we are going to denote it by theta naught. This is given to us as how much? 70 degrees. Okay, I hope I'm audible. Can you just put a message or reply? Am I audible?
Yes, sir. Yes, sir.
Then we are having a dwell phase between ascent and descent. So the angle of dwell, let me denote it as theta d, and it is given as 45 degrees in the problem. Then we are having the angle of return, okay, or it is also called as descent. So denoted by theta r, r stands for return. So this angle is given by 120 degrees. Okay. So the rise stroke or theta naught, this is with cycloidal nature, and the return stroke is with UARM. Okay. Also write down the maximum lift, which I'm going to denote it by H. And as per the problem, it is given as 45 mm. The maximum lift is 45 mm. So I'll be writing H is equal to 45 mm. Okay. So with this given data, we need to first draw the displacement diagram. There's problem with the internet. You just give me a minute. I'll restart the application. Okay, so first step, I'll be drawing the displacement diagram. That is the rectangle whose height will be equal to the maximum lift and the width, which I'm going to represent in terms of the 360-degree rotation. Okay. So height I'm taking it as 45 and the width will be 360. I'm not scaling it down the width, but when you are drawing it in your book, of course, the width you can scale it down. So 360, you can either draw it like 36 centimeters if you are getting that in the landscape. If it's not 36, then you can straight away reduce it to 1:2, make it 18 or so. The next step, I will divide this entire 360 degree rotation of the profile into the rise, dwell, return, and so on. So as per the definition, we are having the first ascent stroke of 70 degrees. So this will be the first division of 70. After this, there is a dwell period of 45 degrees. So this is 45. Then we are having a return stroke of 120 degrees. Okay. So all these things should be common for all the problems. The next step again, we are having this is the rise stroke as well as this is the return stroke, which we need to divide it into equal number of parts. And as I've discussed yesterday, that equal number of parts can be anywhere ranging from 4, 6, 8, 10, and so on. Of course, not only even numbers, you can also make it odd numbers, but as per the standard practice, we are taking as 6 divisions here. So I'll create 6 divisions each in rise as well as return stroke. Okay. So the 7 divisions are made in the rise stroke. Similarly, I'll do it for the return stroke as well. Okay, the numbering and everything I'll be doing in the later stage. Now I need to draw the displacement profile of the follower for the rise and return stroke, depending upon what nature of motion they're having. And as per the problem statement, the rise stroke is having a nature of cycloidal motion. So what we are supposed to do in cycloidal motion, we need to draw the circle. Cycloidal motion means the nature of curve wherever it moves. It is such that it will be always tangent to the rollers that they are passing on. So that is how the cycloidal motion will take place. So I need to find out these roller dimensions over here. So for that, we'll be using the simple equation as h equal to 2 pi r, where r stands as the radius of the cycloidal circle. Okay. So h we are having it as 45, already given in the problem, equal to 2 pi multiplied by r. So from this, r we should be able to get how much is this? 7.16 we get. 7.16 mm. So it's practically impossible to draw the circle with the exact this dimension. Okay, so we can round this off to 7 mm radius. Even 7 mm radius, you cannot use a compass to draw the circle. You need to have that pro circle in which there are circles, right, ranging from 1 mm to so on. I think it's 10 mm or something. You can get the different circles. So you need to use a pro circle in order to draw this cycloidal circle. So let me draw it in the software here. So radius, I'll be taking it as 7 mm. So look at the steps now. I'll focus on the rise stroke now. So I'll just zoom it here, rise stroke. Okay. And I'll be drawing the circle with the initial position of that rise stroke, that is over here. So with the diameter of 14 mm. Okay. I hope this step is clear. The first circle needs to be drawn at the beginning of the cycloidal stroke, that is the rise stroke which is in cycloidal motion. So this is the beginning point. So there I have drawn the circle, and the dimension of the circle we have got it by using the equation h equal to 2 pi r. In the next step, we need to divide these circles into 6 parts such that the first division is always horizontal. So I'll be taking the first division as the horizontal. The second division will be again at 60 degrees. Okay, so 60 degrees, I'm going to get the second division. Sorry, the first division here. Then again, I'll draw the next division at 120 degrees. I'll get it over here. So 60, 120, and next one will be 180. So that will come over here. Then next one will be 240. Next, you can draw it here. Last one is this horizontal. Okay, so I've got this division 1. This is 2. This is 3. This one is 4. This is 5. This is 6th division. And then I'll all make these as a hidden lines. Let me make them as hidden line or a construction line. So the first step, what I'm going to do is I'm going to draw one horizontal line here in the circle. So this is the first horizontal line that I'm drawing here. Okay. I'll change the color of this. The second horizontal line I'll be drawing at the top side by connecting these two endpoints of the divisions in this fashion. And the third horizontal line I will be drawing at the bottom by joining the endpoints of these two construction lines. Like this. Okay, is it clear?
Yes, sir.
Yes, sir.
The next step, what I'll do is from the midpoint of the circle, or in other words, see, I've got three horizontal lines now, right? So this is my first horizontal line at the center which I had drawn. This is my second horizontal line at the top, and this is my third horizontal line at the bottom. So what I'll do is in the first step, I'll connect the midpoint of our first horizontal line, and I will draw a line until the end stroke or end point of this particular stroke, which is over here. Okay, from the center of the circle or from the midpoint of that horizontal line, I've drawn a line up to the end point of the stroke. In the next step, I will draw one more line starting again from the midpoint of this horizontal line, that is at the top one, such that it is parallel to our previously drawn line. I'll just enable the constraints option. Okay, in this fashion. Can you see what I've done? At the top horizontal line, I've drawn from the midpoint so that it is parallel to our previously drawn line. I'll have to repeat the same step for the bottom horizontal line. That is from here, I'll draw a line so that it is parallel to our line. This one. So I've drawn three lines. All three lines are parallel to each other. And from where I have started? From the midpoint of those horizontal lines that I had drawn in the circle. Okay. So you can see this circle. If you want, I'll just delete these construction lines now, not required for me. Okay. Three horizontal line and three midpoints. From there, we have drawn the three lines. Okay. Now let me bring this in our writing pad wherein I can give the numbering for them. Okay, so wherever the bottom slant line is cutting our first division, let me first mark the divisions here. So this will be 1, 2, 3, 4, 5 and 6. Okay, wherever the bottommost line is intersecting our first line, that point becomes P1. And wherever it is intersecting the second line, that point becomes our P2. So the bottom slant line work is over. It will only give us 2 points. Then I'll come to the center line. Wherever it intersects line number 3, that I'll mark it as point P3. Okay, this work is also over now. Okay, it is going to give us only 1 point. Now I'll go to the topmost slant line, and wherever it intersects the point 4, it gives us P4. Okay, sorry. gives us as P4, and wherever the top line intersects the fifth line, it gives us P5. Of course, P6 will be the end of the stroke over here. End point of the stroke is P6. Okay, so these are P1, P2, P3, P4, P5, and P6. You will have to join them by a smooth curve. Okay. Okay, something like this. So smooth curve has to be joined from P1 to P6. Okay. Then there is a dwell period, so there won't be any deviation. So P6 afterwards P7 will come. It has to be at the same height. So this happens to be your P7. Okay, I'll continue numbering at the base. So this will be 0.7, 8, 9, 10, 11, 12, and 13.
Excuse me, sir.
Yes.
Sir, for the circle, we did numbering anti-clockwise. Uh, for the side.
Okay. Hmm.
So what if we do in clockwise? Like the points will get reversed, right? Like P1 will
No,
come on
see.
the top.
No, no, no. For the cycloidal circle you are talking about, right?
Yes, sir.
See, for this cycloidal circle, you do numbering anyhow, whatever it is, clockwise, anti-clockwise. Ultimately, what I want is, I'll just show you here. I'll draw a rough sketch here. Ultimately, what I want is, for a given circle, I want one line to be made at the horizontal. One I want horizontal line at the top, and one horizontal line I want at the bottom. This is how the division has to be made. So, see, suppose this is your division 1, 2, 3, 4, this is 5, and this is 6. So now I've written in anti-clockwise. You can write it in clockwise also. That doesn't make any difference. Ultimately, I'm interested in getting the midpoint of this horizontal line, midpoint of this horizontal line, and midpoint of this horizontal line. Okay. So the midpoint
Sir,
of, yeah.
sir, but like position of P1 and P2 will get changed, right?
No, that's what I'm telling. So once you get these midpoints of these horizontal lines, so this becomes our top line, this becomes our center line, this becomes our bottommost line. The bottom line, wherever it cuts line number 1 and line number 2, you will get P1 and P2 there. The center line, wherever it cuts line number 3, you will get P3 there. And the top line, wherever it cuts, you will get P4 and P5 there. So I'm just using the word bottom and top line here. So because I'm not going with the numbering system, you can do it clockwise or anti-clockwise also.
Okay, okay, sir.
I hope it's clear. Ultimately, the top line should get P4 and P5. The bottom line should get P1 and P2.
Okay, sir.
Okay, so this is how the cycloidal motion can be formed. Now remember, what would have happened if the cycloidal motion was there in the return stroke? If it was there in the return stroke, then the circle would have been coming over here. Because you should always draw the cycloidal circle at the beginning of the stroke. And for this return stroke, this becomes our beginning point. Okay, and you'll have to follow the same procedure again. But now for this return stroke, we have to deal with UARM. So how to do that? So for UARM, it is very simple. Out of these 6 divisions, okay, 6 divisions means okay, in between you are having 5 lines. So I'll just highlight them. This is line number 1, this is line number 2, this is line number 3, 4, and 5. Between inside that stroke, we are having 5 lines. So only 6 divisions are come. So out of these 5 lines, you will have to locate the line which is exactly at the center. So this line becomes, that is the third line, is the one which is exactly at the center. The midpoint of this particular line. So let me mark the midpoint of this line. Okay, see, I have marked the midpoint of the line which is in the middle of that particular stroke. Problem here. Just give me a minute. I'm sorry. Let us not mark the midpoint. Once you locate the middle line, we'll have to divide that middle line again into 6 equal parts. Okay, you'll have to divide this line into 6 equal parts. So let me show it here only. So as per this diagram, the middle line is which one? Line number 10. Okay. So on this line number 10, I will make 6 equal divisions. So this is our first division, something like this. Okay. So these are what? 6 divisions made on the middle line. The first step is from the beginning of the stroke, that is over here, where is a P7, you will have to draw the line connecting the first 2 points. Here. So the first step is from P7 to first point, from P7 to second point I have connected. Okay. From the end point of that stroke, connect to the remaining 2 points. In this fashion. So this is our bottommost point to the end stroke. This is another point. Okay. Let me know if this point is clear. I have chosen the middle most line of the stroke. I have divided into same parts, that is 6 parts. From the beginning of the stroke, I have connected to the first 2 dots. From the end of the stroke point, I have connected to the last 2 dots. Okay, so now look how I'm going to give the numbering for this. Wherever our first slant line is cutting the 8th line, I'm going to make it as P8. The second slant line cutting 9th line is P9. And the center point of the middle line automatically becomes P10. 11th line is cutting over here. So this becomes P11. 12th line is cutting at the end, that is P12. Is it clear?
Yes, sir.
Yes.
So we have to just again join them by a smooth curve. So starting from P7 to P8, then P9, P10, P11, P12, and then P13. Okay, this has to be a smooth curve. So this is how your displacement diagram is going to look. Okay. So this completes 50% of the problem. Now let us go to the cam profile construction. So for cam profile construction, let us see what we have. We are having minimum radius of the cam as 30 mm. That means 60 mm diameter. I need to draw a circle here for cam profile. Okay. Then they have given roller radius. That means the radius follower type is not knife edge. It is a roller, and it is having a radius of 10 mm. So I'll just draw the initial position of the roller. I'll assume that it is at vertically upwards position. Okay. So this is, let us do one thing. We'll draw one more circle now, whose diameter is not 60 but 65. I'm sorry, I think yeah, 70 I'll take. So I've drawn one additional circle whose diameter is 70. Now let me draw one circle over here. I think roller radius was 10 mm, right? Okay. Just a minute. This has to be 80. Okay. Here I've drawn one base circle of 60 mm, the small inner circle over here. Then we have been given that the roller radius is 10 mm. Roller radius is 10 mm. So what I've done is I have drawn an additional circle with the 10 mm on each side. So 60 plus 20, it will be 80. I've drawn a diameter 80 mm circle over here. And then I've drawn this roller radius here, whose diameter is 10 mm or radius is 8 mm. Okay. I hope it is clear now what I've done. To just to draw the initial position of the roller, I have drawn an additional circle. This is going to be called as prime circle now. Okay, the second circle is going to be called as the prime circle, and the inner circle is going to be called as the base circle. Okay, I'll delete all the dimensions here. Once this is done, since this is our starting point.
Excuse me, sir.
Yes, yes.
Can you please repeat that word out for the outer circle?
Yeah. See, this becomes the prime circle now.
Prank.
Yeah, prime.
Prime, okay.
Yeah, PRIME, prime circle, and this inner one becomes the base circle. This is our entire roller. Okay, I'll be writing it. When I take this into the writing pad, I'll just give the proper naming and everything. So this being our start stroke, I'll just teach you for the right stroke. I guess you can do it for the return stroke also by yourself. So the right stroke was how much? I think it was 70 degrees. So I'll draw a line. Make sure that this is 70. Okay. And I'll make 6 divisions. Okay, so we have got these 6 divisions. Since these have to be extended a little bit, I will extend them here now. Some random length. I'm just extending them of random length here. Okay, so let me bring this into the writing pad. Okay, so I'll start numbering. Okay, first let me write this. This is our base circle. This we are going to call it as prime circle. Okay, this is our roller. Okay, and on the base circle, the numbering has to start from say 0, 1, 2, 3, 4, 5, and 6. Okay, so now to get P1 and P2 and so on. If you go to the displacement diagram, so I'll to get P1, what I'll do is I'll set the compass and I'll measure the distance from 1 to P1. So I'll set this distance 1 and P1, this distance. Okay, 1 and P1. From where I'm supposed to mark this now? Let us see what will happen if I mark it from 1 only. From this point 1, I will cut an arc like this and mark this as P1. Now P1 is a point where the roller is just going to touch at that point. I hope you have got it. I'll show you how it looks here. See here. If this is your P1 point, the roller should come somewhere like this. It should just touch here. P1 is not going to happen the center of the roller. P1 is a point wherein the roller is just touching. Now you can make some error here because for this point I can draw a circle like this also, or for this point P1 I can draw this circle in the other direction also. Okay, so I can draw the circle here also. So you can draw the circle here. So there are many possible ways. So I don't want the end point of that circle. So instead what I will be doing is, instead of measuring it from 1, I'll measure it from the prime circle. So if I measure it from the prime circle, what I will be getting is not the end point of the circle. Instead, I'll be getting it the center of the circle. So once I know the center of the circle, drawing the circle becomes very easy. Let us just re-verify this concept for point 0 and see whether we are correct or not. What is the distance of P naught from point 0? The distance of P naught from point 0 is 0 only, right? So here in this diagram, instead of measuring that 0 distance, if I measure from base circle, if I measure it from prime circle, so if I make this actually 0, so from 0, if I measure the distance which is 0, I'll get P naught here only. And once I get P naught, I'll have to just draw a circle of roller radius. I hope it's clear. If not, let us just do it for the point number 1 and see. So whatever 1, 2, 3, 4, 5, 6 I'm having on the base circle, I'll just put them on the prime circle now. So this is my actually point 1 now. This is actually point 2, point 3, 4, 5, and 6. So from point 1, I will measure P1 distance on the displacement diagram and I will cut the arc over here. Okay, I'll get P1. Similarly, from point 2, I'll measure the distance, I'll cut the arc, I'll get P2. From P3, I'll get P3. From point 4, I'll get P4. From point 5, I'll get P5. And from point 6, I'll get P6. Now, these are the center points of the roller follower. So I need to go on drawing the roller follower at every point. So if you actually draw it, it becomes a little bit shabby. So what you can do is by keeping the center as P1 here, and you can set the roller radius as 10 mm and just draw one simple arc here like this. Let me change the color here. A simple arc in this fashion. Then again with center as P2 and same roller radius, draw another arc like this. Then with center P3, you can draw one more arc. With center P4, you can draw one more arc. With center P5, you can draw one more arc. With center P6, you can draw one more arc. Like this, you can just go on drawing partial arcs instead of drawing the complete circle. Once this is done, then we can join these points such that our line which is joining should not go inside the circle. It should be tangent to the circle or the arcs in this fashion. Is it clear?
Yes, sir.
Now, what generally the students have confusion is, I'll just focus, I'll zoom here. What is happening at this third line you can see here? The students think that the green line which I've joined the smooth line, it should touch exactly here, which is not necessary. The green line which are touching the arcs, it need not touch them on those extended lines. It will usually touch those arcs on the left side of those extended lines. You can see that this is the extended line I'm talking about. But where it has joined, actually, it has joined over here, a little bit on the left side of the extended lines. Is it clear? Even the same thing is happening for line number 1 also. See here, line number 1 extended line is here, but it has joined somewhere over here towards the left side. Okay, in the similar fashion, you need to do it for the return stroke as well. I hope you will be doing this by yourself. Okay, do you want me to share this the problem statement which I put in the PPT?
So along with the video which we will be adding that in those comments you can add it.
Okay. Okay, fine. If you have any doubts, please let me know, or else we can wind up the class.
No, sir. Thank you.
Thank you.
Thank you, sir.